Forget the generic intros, let's just dive right into this explainer. We're going to look under the hood to see the literal mechanical and digital magic that keeps your car moving. Today we're demystifying a totally critical yet kinda heavily misunderstood component of your engine, the throttle body.
I mean, think about it for a second. We all intuitively call it the gas pedal, right? That implies this direct mechanical link straight to the fuel tank. But as we know, the reality of modern engineering is way more complex than that. When you press that pedal down, you actually aren't in control of the gasoline at all. It's a huge misconception that we're going to bust right now.
What's really fascinating here is this strict division of labor happening every single time you drive. When your foot pushes down, you're actually demanding air, while the engine control unit, the ECU, basically your car's brain, handles the fuel injection. You demand the air, and the computer does all the complex math to supply the exact right amount of fuel to match it. It's this perfectly choreographed dance, and it's happening hundreds of times a minute.
Okay, let's move into section 1, air, not fuel, the engine's windpipe.
You can think of the throttle body exactly like a human windpipe. You know, sitting on the couch, you breathe pretty slowly. But if you were to sprint down the street, your airway opens way up to draw in massive gulps of oxygen. Well, the throttle body does the exact same thing. It opens and closes to let the engine breathe depending on how much power is demanded. It is the absolute gatekeeper of air.
Let's jump to section 2, the airflow journey, from pedal to power.
So let's map out exactly how your foot's movement translates into that burst of acceleration. It's a brilliantly modern 5-step journey. Step 1, super sensitive digital sensors on the accelerator pedal measure the exact angle and speed of your foot. Step 2, those sensors fire off a signal to the ECU for processing. Then, step 3, the computer instantly calculates what's needed and commands the electronic throttle control, or ETC motor. Step 4, this little motor physically swings the metal throttle plate open. And finally, step 5, a huge rush of air flows straight past the plate and into the intake manifold. And the crazy part? All 5 of these steps happen in a fraction of a millisecond. Literally, before your foot has even finished its downward press, the engine is already gulping air.
Up next, section 3, cables versus drive-by-wire, the evolution of control.
The crucial point here is that this highly digitized, sensor-driven process is a massive leap from how cars used to be built. Older mechanical cable systems physically tethered your foot to the throttle plate with a woven steel cable going right through the firewall to the throttle body. You pushed, the cable pulled, simple as that. But today's drive-by-wire systems, which are standard on virtually all modern cars now, rely entirely on digital sensors and electronic motors. This allows for pinpoint precision, way better fuel economy, and it lets the car's computer seamlessly intervene for things like traction control or cruise control without you doing a single thing.
Let's look at section 4, idle and full throttle, the extremes of airflow.
Let's see how this all builds when we examine the extreme ends of engine operation. Think sitting at a stoplight versus just flooring it. When you're idling, the throttle plate is nearly closed. It's barely cracked open, just allowing a tiny sliver of air to keep the engine from dying. Because the engine's pistons are frantically trying to suck in air, but the throttle plate is blocking the way, this creates an incredibly high vacuum in the intake manifold. It's basically like putting your thumb over the end of a syringe and pulling the plunger. But at wide open throttle, or WOT, when your foot is mashed to the floorboard, that plate flips a full 90 degrees, completely open. The vacuum instantly disappears as heavy atmospheric pressure floods the system, equalizing the pressure and feeding the engine maximum oxygen for maximum combustion.
Finally, section 5, failures in limp mode, when things go wrong. Now, because this system completely dictates how the engine breathes, any disruption is going to immediately impact your daily commute and your safety. Over time, thousands of miles of driving can cause carbon buildup, dirt, and oil vapor to literally bake onto the inside of this component, choking the windpipe. The symptoms are unmistakable. We're talking a rough, vibrating idle, hesitant, or really poor acceleration, and sometimes the engine just flat out stalls when you come to a stop. The plate physically gets stuck on the grime, so it can't close or open to the precise micro angles the computer is demanding. The good news though, a simple cleaning usually restores it completely.
But what if it's an electronic failure, not just a bit of dirt? Remember that drive-by-wire system we just talked about? If the computer detects a broken wire, a failing sensor, or gets conflicting signals about where your foot is versus where the throttle plate is, it instantly triggers what's called limp mode. This is an absolutely crucial failsafe that severely cuts your engine's power, letting you only drive at extremely slow speeds, just enough to literally limp off the highway to safety. It does this to prevent a totally catastrophic scenario where the throttle gets stuck wide open. So it's basically the car prioritizing your life over performance.
So, have you noticed a rough idle lately? The next time your car hesitates at a green light or shudders in the drive-thru, well, you'll know exactly what mechanical windpipe might need inspecting under the hood. It really is incredible how much complex engineering goes into the simple act of letting an engine catch its breath. Pay close attention to how your car responds the next time you press that pedal, because you now know the invisible digital handshake happening right beneath your feet. Which makes you wonder, what other hidden systems are silently keeping you safe on the road every single day?